This is Math 2, 6.2 notes. That's Unit 6, Lesson 2. Proving triangles are similar. Before we get started, I want to quickly give you the 3 similarity statements we will be using. They are angle, angle, similarity, side, angle, side, similarity, and side, 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 similarity. Those are the only 3. I know when we were working with congruency, we had more. But when we're working with similarity, it's just these 3. So, yesterday's lesson, we had to first prove all corresponding angles were congruent, and then all corresponding side lengths were proportional. We don't have to do that anymore. As long as we can prove 2 angles are congruent, we're good. And over here, and this is 2 corresponding angles. Side, angle, side. The sides, whenever you have an S, like this here or this here, you have to prove not that they're congruent, but that they are proportional, because that's what similarity is. All right, are the triangles similar? If not, write not similar. Okay, number 1, I'm going to give you the image. Looks like this. We're going to title this A, B, C. This is 9, 6, and 6. I'm going to give you another one. This is E, F, G, 8, 8, and 12. All right, now, we don't have any angles at all, so I'm going to go straight to the SSS as the one I'm going to try to use. So that's what's going to go here, your statement, not your statement, but your the one you're using, your angle, angle, similarity, side, angle, side, or side, side, side. So going straight to this one since I have no angles, so I'm not going to use angle, angle, or side, angle, side. Now, when you make your extended proportion, and they didn't give you a similarity statement, you work off side lengths, small over small, medium over medium, large over large. These 2 are the same. I would call this small and medium, so it would match with the 8 and 8. So I'm going to put 6 over 8 equals 6 over 8, which equals, and then my large over large. And you have to be continuing to use left over right or right over left. Just continue to do it consistent. Continue to do it the same way. All right, what does it reduce to? 6/8 divide top and bottom by 2. That gives you 3 over 4. Same thing, divide top and bottom by 2, that's 3 over 4, equals here, you're not going to divide by the same thing as you did on these, but you're going to divide top and bottom by 3. 9 divided by 3 is 3, 12 divided by 3 is 4. Check, they all come out to be the same. That means yes, they are similar. Similarity. Okay, so what is a similarity statement? A, B, C. I went along the larger side and then down one of my same sides, the 6s. So along the bigger and down. So because it's isosceles, you could go EF or FE. I'm just going to do EF and up the G. But if you went the other way around, because the 8s are congruent, that is fine. You could have done FE, G. All right, number 2. I'm going to give you the image, and I'm going to call this A, B, I'm going to put a line right here, D, E, C. All right, don't know if you remember these, but we did overlapping triangles before, and this is an overlapping triangle. Now, these parallel markings, it's not a mid-segment because they didn't give us any kind of markings here, but if they ever give you something like this, you're going to redraw, especially when you're working with these similar triangles. First triangle is going to be the ABC. I'm just going to redraw it without the smaller triangle inside. A, B, C, and then the smaller triangle is the DEC. D, E, C. Now we can see that they overlap in corner C. Angle C is congruent. Why is it congruent? Because they overlap in that corner. ABC has angle C, as well as DEC has that same angle C, so it is congruent. All right. Parallel lines, we've talked about the C shape, the Z shape, the F shape. Can you guys see the F shape here? Now you could have drawn the backward F if you wanted to, it doesn't matter. I'm going to use this one. If the arms of the F are parallel, then these little corners here are congruent, and those are called corresponding angles. So angle A is congruent to angle, or BAC is congruent to EDC. And we can see that here, A and D, A and D. All right, now what do we have? I don't have any side lengths, just the two angles, and that is enough. As long as I have two corresponding angles that are congruent, those two and those two, one set, second set, then I can say they are similar, and they are similar by angle-angle similarity. Why? Because I have two sets of corresponding angles that are congruent. All right, ABC. Now when we label this, let's see, ABC, I go from two angle marking to none to one. Two, none, one. Two, none, one. That's DEC. All right, and the next one, number 3, is going to be those bow tie problems that we've done before. I'm going to make this one over here a little bit smaller. Okay. I'm going to call this A, B, C, D, E. Okay, I'm also going to give you that AC is 3, and I did draw this incorrectly, so I'm going to change this. This is going to be 6. This one's going to be 10, 4, and 3. Okay. Now, what do I have? I have two sets of side lengths, and that's it. Do I have this side? No, so I cannot use side, 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 even if I wanted to. But I do know vertical angles are congruent, so if there's anything I'm going to use, it's going to be the side angle side, similarity. But I have to check that side lengths, corresponding side lengths are not congruent, but they are proportional. So again, they didn't give us a statement, so we need to use small to small, large to large. Okay, small is 6, small over here is 3, so 6 over 3 equals large to large. 10 is larger than 6, 4 is larger than 3, so 10 over 4. Again, you're going from left to right, so 6 to 3, 10 to 4. This reduces to 2 over 1. When you divide top and bottom by 2 here, you get 5 over 2, and those are not equal, so we would say not similar. I'm going to just put an X there and write not similar. They are not similar because the corresponding sides are not proportional. All right, back side. A 1.3 meter child is standing next to a flagpole. The child's shadow is 1.1 meters long. At the same time, the shadow of the flagpole is 6.8 meters long. How tall is the flagpole? All right, here is the flagpole. It's the ground. And a child is standing next to the flagpole. And the child is 1.3 meters tall. And do we know, let's see, child is 1.3 meters tall, standing next to a flagpole. The child's shadow is 1.1 meters long. From here to here is 1.1 meters long. At the same time, the shadow of the flagpole is 6.8. So all of this here is 6.8. And how tall is the flagpole? Okay, so this is your X. This here is what we're looking for. We don't know how tall the flagpole is, so that is your X. Okay, so sun is shining, same time of day for the measuring of both shadows. Remember, shadows are always on the ground. They never hover in the air. So your shadow, this is never your shadow length. Your shadow length is the ground, So never try to put it up at the hypotenuse. Okay, so these two triangles are similar because you're working with the same time of day and you have a right angle in here. They are similar. I'll explain more in class, but right now I'm trying to get through this before we run out of time. So I will explain. So right now, just know they are similar. I'm going to redraw them. This is the flagpole, X 6.8, and this is the child. The child was 1.5 and 1.1, and so we make our proportions. Height over height equals shadow over shadow. So X over 1.5 equals 6.8 over 1.1. And you will cross multiply, so you will need calculators to do this, so make sure you have one. If not, hit pause and then go and grab. Okay, so we did height over height equals shadow over shadow, and you need to be consistent. Flag over child, flag over child. Cross multiply, 1.1 times X is 1.1X equals, you can plug in your calculator, 6.8 times 1.5 is 10.2. And then I want to solve for X, so I'm going to divide both sides by 1.1. X equals, and let's round to 2 decimal places, that's 9.27 or 28. That would be 27 because what comes after the 7 is a 2. I don't know if you can see that or not. 9.27. So 9.27 meters is the height of the flagpole. All right, I'm going to have you attempt to draw number 5 and try the best you can. It is different from number 4, but do the best, and we will talk about it together in class. That is it for this lesson.